So we're doing June 2015 S1 paper. The first thing I notice is only 6 questions, which is a bit unusual. Anyway, let's see how it goes. First question is kind of interpreting and representing data question. This is an outlier, but we still include that in our range. So it's 48 is the highest, and the lowest is 9. So 48 take 9. Which is 37, which is the range. The interquartile range is the difference between those two, which is 25 take 12, which is equal to 13. So that's pretty straightforward, pretty easy to get going. Then we've got to do a bit of linear interpolation, because the data was about estimating an angle of 20 degrees, and then they go on to estimate 70 degrees. Now there's 60 of these students in total. It does say that earlier on, but these numbers add to 60. What we do when we do linear interpolation is we make an estimate. That's basically the key. It's an estimate. Okay. We've got 60. We do tend to divide that number by 2, not add 1, although they do accept to look at the 30.5th. But we're looking for the 30th, or an estimation of the 30th. Now let's put my answer up here. So write it up there. But we've got the 30th. If we look at this, we've got the first 6 there, and then we've got up to 21 here and up to 34 here. So the 30th is in this group. So we're estimating, we know that it's somewhere between the lower class boundary, which is 65, and the upper class boundary, which is 70. Okay, now what we do is we now make an estimate. We've got 13 in this group entirely, but we've got 21 from before. So we want the 9th out of 13 an estimate of. So we basically kind of make a guess. Okay, so change colour pen. Basically we've got 13 through that group to cover the group 65 to 70, 13 data values. We make an estimate of where the 9th one would be. Remember, it was 9 because we've got 30, take away the 21 that were in the 2 groups from before. So that basically enables us to set up a kind of a calculation for it. We have Q2, the median, or the median if you prefer, is 65, or remember it's an estimate, plus the 9 out of 13 times by the class width. Notice it's 10 from here, not 10, it's 5 from here to here. 65 take 70, so it's times 5. So we're making an estimate. So this is always a fraction, less than 1. Okay, and this is the class width because we've got between 65 and 70. And when we work that calculation out, that equals to 68.5 for part C. Then for part D, they say show that the lower quartile is 63. Not entirely happy with the word in there. It's an estimate, so they really should say show that an estimate for the lower quartile is 63. But they haven't. So, but it must mean that. It can't mean anything else. So now if we're looking at the lower quartile, we're now doing 60 divided by 4. That's the 15th. If I rub this lot out now, the 15th, we've got 6 and up to 21. The 15th is here. Okay, so we have the 15th in there. So that gives us, and we've got 6 from before. So that basically means 9. So an estimate for our lower quartile, the lower quartile, well, let's do the little diagram like I did before. We're going between 60 and 65. Okay, class width of 5 again. So that means that our estimate for Q1 is 60, because that's the lower class boundary there, plus the fraction, the estimate of how far into the group it is 9 out of 15, times by the class width, which again is 5. And that equals to 63, which is what they've asked us to show. Okay, so then it says, it gives us some more information. It says for the upper quartile is 75. That's just so that we don't have to do that calculation again. It's a bit unusual for them to do us twice, so they're not going to ask you a third time. So Q3 is 75, and they got the minimum is 55, and the maximum is 84. So they're telling us that. Right, well, let's just work out what the interquartile range is, which is Q3 minus Q1. So that's the 75 here. Take away the 63 here. So that equals to 12. Okay. And so therefore what we're looking for is the upper boundary. And we're basically finding a number, and if any numbers lie above that boundary, then there's an outlier. So the upper boundary, they're telling us what it is. It's more than 1.5 above the upper quartile. So in other words, Q3 plus 1.5 times IQR. And that equals to, well, Q3 is 75 plus 1.5 times 12. And that equals to 93. But the largest value we're told is 84. So that means there's no large outliers. Okay, so then we find a lower, let's find a lower boundary. Similar idea. We're basically looking below the lower quartile now, 1 point. So the lower boundary is Q1 take away 1.5 times IQR. So that's equal to, the lower quartile was 63 minus 1.5 times 12. So that equals 45. But the lowest number, the lowest value we are given is 75. So that means that there's no small outliers. And that's our 5 marks. Okay, there, oh, it's not yet, because it asked us to do a box plot. This was actually in the next page of the on the answer in the question booklet, but I've copied and pasted it here. Right, so the lowest value we're told is 55. So that's there. The lower quartile is 63, which is there. And the median is 68.5. Now I do use a ruler here. It's a bit difficult for me to do it here, but I'm doing it for speed, but you should use a ruler. And then the upper quartile is 75. So my box is there. And then the largest value is 84. So there's my box plot. Right, now F, it says state with reasons. Well, a couple of things here. The median for 70 degrees is closer. And if you look at it, the range is closer as well, because if you look at the original diagram, this including the outlier in any case, this here, the range is much more. Range and the interquartile range is much more. Not much more, but more. But range and interquartile range is much less, sorry, for the... Now, when both of those are the case, we'd have a bit more of an issue if the range for one of them, suppose if the range for this one was actually more and a lot more, we might say that 20 degrees was better because, you know, it's no good them being all spread out. But here, because the median is closer and the range is smaller, clearly they're better at estimating 70 degrees. Okay, well, a bit fiddly, but not too bad. Okay, let's have a look at question 2. Okay, so it's coding with correlation. You might be tempted to set up a simultaneous equation here with, say, these values. So you could write 4 is equal to 184 or 4.0 is equal to 1840 minus A divided by B, and also do 4.8 is 1848 minus A divided by B, and work out A and B simultaneously using, because it's a simultaneous equation. I suppose looking at it, we should see that it's going to involve dividing by 10, because we've got a difference of 8 here and a difference of 0.8 here. So I can see that B equals 10 from that. And then once we've got B as 10, we can put 10 in for B here. That quickly should get us to 40. So that gives us A is 1,800. So it's okay to write the answers down if you can see it there, because there's only 2 marks, but solving wouldn't take too long if you wanted to. Okay, so it says the estate agent recorded the distance, d kilometres, of each house from the nearest station. They are put in this table below. Find the product moment correlation coefficient. I'm just going to scroll down to the formula you've got here. You're given the product moment correlation coefficient here. Okay, so that's R equals to the one with 2 of them, that's minus 2.17, over the square root of these 2 times by each other. Okay, and that equals to minus 0.749 to 3 significant figures. Don't round to 2, always round to 3 as a bare minimum. Okay, minus 0.749, part B. Now, then it says write down the value of the product moment correlation coefficient. This is an important principle, only 1 mark here. It's going to be the same. Coding has no effect whatsoever on correlation between 2 sets of variables. So if whatever the code is for R will be the same for Q, and that's it. Okay, now the next bit says estate agents records the price and size of 2 additional 2-bedroom houses, H and J. And looking at this, suggest which houses are more likely to be closer to a train station, justifying the answer. Well, let's look at the original data here. Okay, this is to do with the price per square metre for 7 2-bedroom houses. Okay, So the first thing we really need to do is find the price per square meter for this. So let's find the prices per square meter. So for house H, that's 156,400 divided by 95 divided by 85. So that equals 1840. And then for J, that's 172,900 divided by 95. So that equals to 1820 per meter squared. Okay, so the cheaper one is this one, is J. So, but there's a negative correlation between them. So in other words, we're going to expect a higher price for the one that's closest. So since the distance is negatively correlated, we would expect the highest price per square meter the closer price per square meter to be closer to the train station. But H is the highest price, so that means H, expect H is closer to the station. And that's it.